Is it possible to use argsort in descending order? Consider the following code. This gives me indices of the n smallest elements. Is it possible to use this same argsort in descending order to get the indices of n highest elements?
If you negate an array, the lowest elements become the highest elements and vice versa. Therefore, the indices of the n highest elements are. Another way to reason about this, as mentioned in the comments, is to observe that the big elements are coming last in the argsort. So, you can read from the tail of the argsort to find the n highest elements. Both methods are O(n) log n, in time complexity, because the argsort call is the dominant term here. But the second approach has a nice advantage: it replaces an O(n) negation of the array with an O(1) slice. If you're working with small arrays inside loops, then you may get some performance gains from avoiding that negation, and if you're working with huge arrays, then you can save on memory usage because the negation creates a copy of the entire array. Note that these methods do not always give equivalent results. If a stable sort implementation is requested to argsort, for example by passing the keyword argument kind equals merge sort, then the first strategy will preserve the sorting stability, but the second strategy will break stability, i.e. the positions of equal items will get reversed. Example timings. Using a small array of 100 floats and a length 30 tail, the view method was about 15% faster. For larger arrays, the argsort is dominant and there is no significant timing difference. Please note that the comment from Nedim below is incorrect. Whether to truncate before or after reversing makes no difference in efficiency, since both of these operations are only striding a view of the array differently and not actually copying data.
Just like Python, in that, column -1 reverses the array returned by argsort and column n gives that last n elements. The advantage of this method is that it is a view of dists. The own data being false indicates this is a view, not a copy. Another way to do this is something like the problem is that the way this works is to create negative of each element in the array and creates a copy to do so. So if you time each, with this very small dataset, the view method is substantially faster and uses half the memory.
Instead of using np.argsort, you could use np.argpartition, if you only need the indices of the lowest/highest n elements. That doesn't require to sort the whole array but just the part that you need, but note that the order inside your partition is undefined, so while it gives the correct indices, they might not be correctly ordered.
As at Kanmani hinted, an easier to interpret implementation may use numpy.flip, as in the following. By using the visitor pattern rather than member functions, it is easier to read the order of operations.
If you want to see more, please consider subscribing.